We're going to be working with sectors and areas of circles here. So we have our question, so we'll read it and pull out important information. A sector of a circle with an angle of 90 degrees has an area of 100 centimeters squared. So that means that sector has the area of 100 centimeters squared. Determine the area of the circle, in other words, the larger circle. So what is our important information? Well, we're referring to a sector, so a sector with an angle of 90 degrees. So a sector has a 90-degree angle, has an area of 100 centimeters. I was having trouble typing again. Essentially that, not squared, but squared. Okay. Determine the area of the overarching circle. So let's again draw a diagram. Tends to be relatively helpful. Here's our circle, and we have a sector. I've set this very nicely for myself. A sector that has an angle of 90 degrees. That would be this sector here. Okay. There's a 90-degree angle. It also happens to take up 100 centimeters squared of space. So determine the area of the circle here. Okay, well, we know that. We don't know the radius, so we can't calculate the area the traditional way. But what we can do is we can figure out that this is a portion of a circle. How large of a portion? It very clearly looks like it's a quarter, but we can prove that it's a quarter as long as we know all of the degrees in a circle. So we know that this is 90, and it turns out the rest of this would be 270 degrees. So in total, a circle has 360 degrees to it, which is a fact you need to know to use this style here. So because it's 360 degrees, well, this sector here, let's say it's in red, is taking up 90 of 360 degrees. Works out wonderfully. If that's the case, okay, 90 of 360 degrees, and we know that the 90 portion happens to make up 100 centimeters of the area, what would the area of the entire circle be? Okay, so not just the rest, but the entire circle altogether. So we've just set up a really nice ratio for this. So what we did is, the formula was essentially degree of sector divided by degree of circle. So essentially degree of a portion over the degree of the whole is equal to the area of sector over the area of the whole, or the area of the circle. Same idea. Why would this work? Okay, that's essentially the formula we set up there. I'll rewrite it again. It was 90 over 360 was equal to 100 over an unknown value. Why does that work? Well, this is essentially a percentage. So we'll use our scientific calculator. There it is. Scientific calculator to figure this out. 90 divided by 360 happens to be 0.5. It is kind of like a percentage, okay? So this equates to 0.25, also known as 25% of the circle, which is exactly what we stated before. We said it was about a quarter of the circle. Very obviously it was. So this is 25% of the circle. Is equal to 100 over x. Well, we need to isolate for x, okay, because it's division on this side here. Because that's a division side, when we go to bring it over, we're going to have to multiply by. So we're going to get x, let me turn it back into black, x times 0.25 is equal to 100. What does this mean as a general statement? Well, this means, remember, this is representing the, go back up, the area of the circle, okay? X was the area of the circle. The area of the circle times a quarter is equal to 100. That's right. The area of the circle, 1/4 of it is 100 centimeters squared. So how do we solve x? Well, because this is multiplication here, the exact opposite of what we did to move the x over, we're going to divide both sides by 0.25. On this side, it's known as canceling out, but essentially creates a 1, and 1 times x is just x. So x is equal to 100 divided by 0.25. Bring up our graphing calculator, or sorry, our scientific calculator again. Let's go to the next line. 100 divided by 0.25 equals 400. Makes sense. If a quarter of something is 100, then the whole would be 400, and it would be centimeters squared. Okay, so we've set that whole question up. The entire area of the circle must be 400 centimeters squared.